Assalamualaikum. My name is Syahier bin Sari, 1625383.
My name is Syafiqah binti Muhammad Safian, metric number 1622056.
Assalamualaikum. I am Nazurah binti Muhammad Noor, metric number 1624948.
Assalamualaikum. Hi, I'm Adawiyah binti Osman, 1629710. Tank measures the level volume of filling freshwater cargo, fuel and oil. Controlling of level in multiple tanks is very common in water purification, petroleum and food between industries. So, Laplace transform is the one of the important method used in this concept. The objective of this project first is to find out the mathematical modeling for two open compartment systems. Second, to investigate and apply Laplace transform in differential equation in mixture of two compartment open system and certain areas. And the third one is to solving equation by using computer algebra system. Differential equation plays an important role in every field to solve mathematical problem. As in our project, two compartment open system, differential equation is used to recognize the equation of water, while the amount of salt between two compartments is calculated using application of Laplace transform.
The mixture into compartment open system is one of the applications that involve the use of system of linear differential equations. For the mixture into compartment open system for this project, it includes two tanks of solvent, in which one of them is a solution made up of salt and water. This solution produces brine as the result. It also includes the flow of water in some particular rate. In this case too, the two compartment open system has output from the system but has no input to the system. By the end of the calculation, the amount of salt in the system will be obtained. Next, I will explain the flow of salt water between the two tanks.
In this project, tank 1 contains 50 kg of brine, in which 12 kg of salt has been dissolved in it. Tank 2 contains 50 kg of water containing no salt. The water without salt flows into tank 1 at 8 kg per minute. The mixture in tank 1 flows into tank 2 at 9 kg per minute. The mixture in tank 2 flows back into tank 1 at 1 kg per minute and out of the system at 8 kg per minute. Let xt and yt denote the amount of salt in kilograms in tank 1 and tank 2 at time t. Now this is the mathematical form in the form of ordinary differential equation regarding the transportation of brine in the two compartment open system, tank 1 and tank 2. So xt is the amount of salt in kilogram in tank 1, and yt is the amount of salt in kilogram in tank 2, and t is the time taken for the transportation of brine between the tanks in minute. And at t is equal to 0, xt is equal to 12, and at t is equal to 0, yt is equal to 0 too.
Next, I will explain the manual solution part. For the manual solution, we need to find the value of xt and yt from equation 3.1. dx dt equal to 1 over 50 yt minus 9 over 50 xt, and equation 3.2 dy dt equal to 9 over 50 xt minus 1 over 50 yt minus 8 over 50 yt with initial condition x0 equal to 12 and y0 equal to 0. First, we need to perform Laplace transformation on equation 3.1, and we get sxs minus x0 equal to 1 over 50 ys minus 9 over 50 xs. Then we substitute its initial condition in 3.1 into 3.4, and we get sxs minus 12 equal to 1 over 50 ys minus 9 over 50 xs. Then we rearrange the equation 3.5 until we get ys equal to 50s plus 9 xs minus 600. Next, we perform Laplace transformation on second equation, which is equation 3.2, and we get sys minus y0 equal to 9 over 50 xs minus 9 over 50 ys. Then we substitute its initial condition in 3.2 into 3.8, and we get sys equal to 9 over 50 xs minus 9 over 50 ys. Then we rearrange the equation 3.9 until we get s plus 9 over 50 ys minus 9 over 50 ss equal to 0. Next, we substitute equation 3.6 into equation 3.11 and we get s plus 9 over 50, 50s plus 9 ss minus 600 minus 9 over 50 ss equal to 0. And then we rearrange the equation 3.12 until we get ss equal to 600s plus 108 over 50s squared plus 18s plus 36 over 25. Next, we find the partial fraction for equation 3.13 and we get xs equal to 300 over s plus 3 over 25 plus 300 over s plus 6 over 25. Then we compute inverse Laplace operation on equation 3.14 and we get xt equal to 300 exponent negative 3 over 25t plus 300 exponent negative 6 over 25t. Next, we substitute xs in equation 3.14 into equation 3.6 and we get ys equal to 50s plus 9 times 600s plus 108 over 50s squared plus 18s plus 36 over 25 minus 600. And then we expand the equation 3.16 until we obtain ys equal to 108 over 50s squared plus 18s plus 36 over 25. Next, we find the partial fraction for equation 3.17 and we get ys equal to 900 over s plus 3 over 25 plus 900 over s plus 6 over 25. And then we compute inverse Laplace operation on equation 3.18 and we get yt equal to 900 exponent negative 3 over 25t plus 900 exponent negative 6 over 25t.
Next, we use Maple to find out our computer-aided solution that give the same answer with manual solution. Then, we plot the graph. As you can see, for the xt graph, the amount of salt is inversely proportional to the time taken. While for yt graph, it shows an increasing trend for the first 7 minutes and then decrease until both graphs result to the same point. To conclude, a mathematical model for mixture into compartment had been studied. Throughout this project, we had determined the amount of salt transported in the mixture after tea time. We solved the equation manually by using the Laplace transform method and we found that the solution is same with the result in the Maple, where the result is. There are some recommendations to improve this project. Firstly, we can solve the equation manually by using metric method. And instead of using Maple, we can use other applications such as Mazima or MATLAB to plot the graph. On the other hand, to improve this model, we suggest that both water and salt to be diluted equally, so that the concentration of salt do not be too saturated that cause the calculation to be imprecise.